Computers are notoriously bad at generating random numbers, to the point where programmers are relying on using tricks, such as using your mouse movement to add entropy to the system, or using dedicated hardware that makes use of nuclear decay to extract randomness out of the unpredictable radiations. Random number generation is also compute intensive, which has been a performance issue in the past. If you look at the source code for the original Doom game, you will see that RNG is a simple, pre-scrambled list of integers, and anytime you need a random number, the system just takes the next one in the list and hopes you won't notice. Today I want to join the fight and research more random number generators. I'm Leonard, by the way. Welcome to Useless Game Dev. This is a Tamagotchi, and I swear this will become relevant later, just bear with me for now. Tamagotchi is an electronic pet companion that was released in 1996 by Bandai. You can feed it, play with it, clean its poop, it sleeps at night, just like a real pet. A few years ago, Randall Munroe, creator of the brilliant webcomic XKCD, proposed the idea of running a simulated network of Tamagotchi where they live and play and eat and sleep. That's what we're doing today. We're going to make a legally distinct simulation called Cute Cat Creature Pals, or CCP for short. The creature lives in a device and has 3 stats: food, rest, happiness, all ranging from 0 to 100. These stats are initialized pseudo-randomly based on the ID of the creature. At every tick of the clock, every step in the simulation, the stats will decay by a certain amount. To get these stats back up, the creature has a state machine to decide what to do based on how they feel. If food falls behind a certain threshold, they will switch to state eat, during which the food stat increases by a set amount at every step in the simulation until they are full. Similarly, if they are too tired, they will switch to state sleep to get some rest. By default, they are in idle state or play state, and their happiness increases. That's one creature done, and it could run forever with this simple state machine. But for the purpose of today's video, which again, bear with me, is going to make sense eventually, we're going to need something a lot more complex. So we will add more creatures. Here's a simulation with 10 creatures, and we're going to add the ability to visit each other. Let's see, so when a creature is at home and doesn't have much to do, they're rested, they're not hungry, the state machine will now decide to start traveling to another creature's house. The ID of the creature we want to visit is also initialized using the creature's ID as seed. Traveling takes 4 simulation steps, and upon arriving at the house of the target creature, they will switch their state to visiting. Look at how happy they are. While visiting, their happiness stat increases significantly faster. After 10 simulation ticks, the visitor will travel back home. Now obviously, the simulation continues, and if the host is hungry and needs to eat, both creatures will eat together. If the host gets sleepy, they will not go to sleep unless they reach a critical threshold, in which case they will kick their visitor out in order to get some sleep. Upon returning home, the visitor will increase their next visiting target in order to visit a different creature next time. Of course, sometimes popping in unannounced at your friend's house doesn't work out. If a traveler reaches another house and the host isn't available, either asleep or already hosting someone else, or they're themselves away on travel, the traveler returns home. We now have a simulation of 10 creatures, but that number is configurable in the constructor, so we could have 1,000 creatures if we wanted. And here's the part where we finally circle back to random number generation. This is all a rather complex bundle of stats, states, ideas, and at any point in time, you wouldn't be able to predict the next state of the simulation without knowing the entire state and running the code yourself. Which means we could take the simulation, convert it to bytes, then brutally cast it to an integer, and that's a perfectly valid random number. We just need to write a quick class that initializes an internal simulation of creatures and provides an interface to generate a double, an int, a number in range, you name it. And with every call to the RNG, the simulation advances one step. It's a bit more compute intensive than using system.random, but to be honest, it's not that much work for modern CPUs. Now what the bonus? Since this simulation is initialized from a number of creatures and a seed, the state after an arbitrary number of steps in the simulation is actually deterministic. It's hard to guess, but it's deterministic, which means you could use this to produce authenticator tokens. those hardware key fobs could totally run a simulation of a few hundred Tamagotchi to generate tokens. A small Tamago village in your pocket. Heck, maybe they already do for all we know. Of course, this is random, but not random. A fair way to decide on a random number could be a democratic process. Asking strangers on the internet is always a good call in all situations. So we will head to the town square of the internet, Twitter. What could go wrong? Let's make a simple Twitter bot. When calling it with a range of numbers, it will post a tweet asking strangers to respond to the thread with a random number in that range. Now, you will need to trust them to actually respond with a number and not memes, but people on the internet are trustworthy. And obviously, while you're waiting on a number to be provided, the main thread in your game or program will be stalling, awaiting a result. And that might take a while depending on your follower count and the tantrums of a billionaire. Of course, this is random but can always be manipulated by an adversary. What is globally accepted as a fair random generation method is rolling dice. So we're going to build a dice launcher thrower device thing. What I'm imagining is a box in which there's a die. The die is placed on the plate, which itself is mounted on springs. And then some motors will apply pressure on the plate, and when they release the plate, it will shoot up, be stopped by these solid stops here, and the momentum will propel the die upward against the top of the box. Alright, it's now time for a build montage. Finally, after much trouble with the springs and the motors and everything, here's the finished box. There's a Raspberry Pi, a few buttons and stuff, and then a lot of cabling to the motors. And this is it. I did make walls for it, but it was too tedious to access the die in the middle and reposition the plate between attempts, so I didn't install them. In the end, it sort of works. But as you can see, the motors, despite being all set up the same way, don't apply pressure in the exact same manner, and as a result the die isn't properly shuffled, it's barely toppled. I would have expected it to be propelled higher like this. Also, the whole system is pretty unstable. The plate keeps sliding around. I really should have added some sort of guardrails to guide it vertically. Maybe I should stick to software engineering. Speaking of, the die being shuffled enough, we can film it with this Raspberry Pi compatible camera. It's pretty low resolution, but it works fine in our case. The program must then apply some treatment on the image to binarize it and count the black clusters on the die. Of course, similarly to the Twitter bot earlier, your game will be interrupted every time there is a need for a random number. The good thing though is that if the 1 to 6 range isn't right, the game could prompt the user to change the dice inside the box to insert either a die with more faces or just multiple dice. There you go, that's 3 random number generators that are totally 100% viable options for your game project or your Bitcoin exchange platform. Sorry this video took a while to come out, I've been swamped with work and also trying to finish the Stardew Kitchen project, which you should check out on the second channel if you want to see me cook all the recipes from Stardew Valley. Anyway, the Tamagotchi source code is available on the Patreon, and until the next video, have a good one!